Hey, physical science kids, Mr. Tima here. Going to go kind of quick, so you might have to rewatch this a couple of times, but we're going to talk about this is Astronomy Notes Part 3, and we're talking about the life cycles of stars. Okay, so we're going to start with our sun because that's the one that we worry about the most, and we consider our sun to be an average to low mass star, but average mass star. So our star started in something called a nebula, which is kind of like the cabbage patch of stars, if you will, and then it becomes a baby star, which is known as a protostar. It then becomes what's considered a main sequence star, which, if you just did that thing on the Hertzsprung-Russell diagram, that's that big part in the middle. Okay. Our sun will then become what's called a red giant. It will go through what's called a level 1 supernova. It will then become a white dwarf, and then eventually it will become a black dwarf. And we're going to talk about what each one of these things are here as we go through here. But again, you will need to know the order or the life cycle of our sun. Okay, so yeah, you will have to match the names up to these things. Okay, so star formation. All stars begin with the condense of gas, ice, and dust called a nebula. Okay, these particles condense with gravitation, like hard. It kind of all condenses down these particles, and then it's like at 1 million degrees Kelvin, it like lights on fire. All this matter gets together, causes internal friction, and it lights up like a match. And all of a sudden, we get the first spark. And that first spark is called a protostar. It's a baby star. Okay. At about 10 million degrees Kelvin, it starts fusing. Fusion begins. And then basically what happens is that's when the first light is produced. So a baby star, just like a baby inside the mother, is in there and it's alive. You can't really see it until it's born. It doesn't get born until it hits 10 million degrees Kelvin. And that's when it kind of starts producing light. So again, a protostar, then our sun kind of grows and becomes a main sequence star. Well, when it goes through a main sequence star, it then becomes a red giant. So if our sun is this little yellow dot, what happens is the inner part of the sun starts to contract or fuse together into heavier elements. All the hydrogen in our sun starts becoming helium. Okay. And then what happens is the inner core contracts and the outer core expands. And what's going to happen is the outer core, the outer part of the sun, not the core's on the inside. The outer part of the sun is going to expand and it's literally going to destroy Mercury. It's going to destroy Venus. And it's going to come all the way out to the edge of the Earth. And our atmosphere, unfortunately, will be vaporized. Okay. That'll be the end of Earth as we know it. The atmosphere is going to vaporize and it's going to be shedded out to space, and temperatures on Earth are going to become incredibly hot. It's going to be like we were the third planet from the sun. All of a sudden, we're going to be the first planet from the sun. So what happens there is then those outer layers, when that outer layer is released, that red giant's going to kind of come out. It's going to release its outer layers, and that's called a level 1 supernova. Okay. And then what's going to be left over is something called a white dwarf. And a white dwarf, after the red giant's core contracts and becomes hotter, all the helium's used up, and basically that outer layer moves away, and the helium fuses then to carbon. And basically now a star is incredibly small. I mean, our sun, which we saw on the one video about the size, is much bigger than Earth. But our sun will only be about the size of Earth. The core will be left over. It'll be incredibly, incredibly hot, but not very bright. Remember on the HR diagram, those white dwarfs are in the lower left-hand corner, so they're much dimmer, but they're super, super hot. And then just like, if like at a barbecue, when that ember, that really, really hot but not super bright thing at a barbecue or at a bonfire, eventually it's going to burn out and it becomes a black dwarf, which means it's just basically a big piece of carbon out there, and basically all light stops emitting from it. So what if we started with a star that has much more mass than our sun? So this is a life cycle of a large mass star. Okay. Well, again, everything starts out the same. It all starts out with a nebula. It then becomes a protostar, a baby star again. But this baby star becomes a bigger person. Okay. It's a main sequence, but like a large mass star. It still goes to the main sequence, but it has a lot more mass. This would be like the Mr. Tima of stars. Now, it doesn't become a red giant, it becomes a supergiant. And most of them become red supergiants, again, Mr. Tima style. Well, since it has such more mass, when it contracts, it becomes what we call a level 2 supernova. And that's the one that you've probably seen and that was in the Cosmos video and everything. It's a huge, large explosion. It becomes a neutron star, which we'll talk about, and then it becomes what we call a black hole. So, a supergiant, much more mass than our sun. The core temp is hot enough to cause fusion of products into heavier elements. The star expands. Instead of getting to carbon like a piece of charcoal, it forms an iron core. So basically, it becomes basically like a giant grenade. It has this metallic core that fusion can't come out. And what happens is just like if you lit off a firecracker in your hand, if your hand's open, it's going to burn your hand. If your hand's closed and you lit a firecracker, you know that your hand could actually like blow off. Well, that's what we're talking about. Basically, gravity's pulling in and there's this gas pressure, this fusion that keeps it kind of stable. Well, eventually the gravity outdoes the pressure outward and it kind of collapses in itself. We think our sun's about halfway through this right now. Okay. So here's where we're at. We're changing to hydrogen to helium, helium to carbon. That's where our sun's going to stop. But the next stage would be neon to oxygen to silicon to iron core. Eventually it comes in, and then we have a massive explosion. And that massive explosion is called a supernova. Okay. When this blows up, it's not like if the earth blew up or if there was an explosion and there's chunks of things everywhere. This is an explosion of matter itself. This thing is not just spraying out protons, neutrons, and electrons. It's throwing out plasma. It's ripping apart the foundations of matter. That's how incredibly powerful this explosion is. Remember, a level 1 supernova, like our sun, is basically when the red giant just kind of sheds those outer layers. Think of it like a giant fireball blanket going out into space. But level 2 supernovas is the big one. That's the one that's the giant explosion like we just talked about. And it's going to create what we call a neutron star and a black hole. So what's a neutron star? A neutron star is when all of this matter collapses in on itself. It's this incredibly dense piece of material. The typical neutron star is the size of a major city on Earth, but its density is so dense that it is like a cruise ship packed with people. Okay? So what does that mean? That means if for some reason I could go to a neutron star and I could take a teaspoon or like a spoon you eat your cereal with, and I scooped up a piece of neutron star, that piece of neutron star would be so dense. It would be like a cruise ship packed with people. So the size of a major city. Imagine if we lifted Franklin County off the map. If I lifted Franklin County off the map and I made it into a sphere, that's how big a neutron star would be. But it's more dense than like 100 times our sun. It's incredibly dense. Well, and eventually everything continues to collapse so much that light itself cannot escape. And that's called a black hole. So you may, if any of you watch Futurama, you may have seen this little part. But what is a black hole? Well, a black hole is made up of two things. It's made up of a singularity, or we like to call it like the little point in space. That's where the word singularity comes from. Okay, where all of this begins. But there's this part called the event horizon. And the event horizon is basically the point of no return. If you cross the event horizon, that's it. You're going into the black hole. You're going into the singularity. It's like you're fine, boom, you're in there. You can almost think of it as like the edge of quicksand. Once you hit that event horizon, you're done. And we'll talk about something cool about the event horizons and stuff when we meet in class. So I want you to think about something real quick. If I cross the event horizon, where do I go? What happens to me? Well, there's a lot of people that think that once you cross that event horizon, the gravity is so incredible that you don't get just sucked in. Your body is ripped apart, basically to the microscopic and nano levels. It's just gone. Everything just gets ripped apart. It's not like you go down a water slide at a water park or those like tubes or whatever. This is At the fundamental plasma level, you no longer exist. Okay, got 2 little short videos for you to watch here. Pretty cool. Little refresher, little review.
Of course, a star may live for billions of years, and stellar age has nothing to do with lifestyle or heredity. It's all about size. Smaller stars burn cool and dim. When their fuel burns out, they just fade away. A medium star, like our sun, will burn steadily for some 10 billion years. But when it finally runs out of hydrogen fuel and gravity grips the core harder, the star grows hotter and the outer layers puff up, engulfing nearby planets in its fiery demise. Finally, the outer layers blow off into space and a dense solid core remains. This white dwarf is a dying star. A bigger star, say twice the weight of our sun, lives hot and dies young. It burns through its fuel in just millions of years, and it doesn't go quietly. There's more material here for gravity to constrict. The star goes out with a bang called a supernova. Gravity packs the remains into material far denser than white dwarfs, called neutron stars. A teaspoon full of this stardust weighs more than a cruise ship packed with people. Some enormous stars gone supernova become so dense they turn into black holes. Think about it. A massive explosion leaves gravity unchecked, and matter is squeezed into something unseeable, stretching as far as miles and weighing incomprehensible amounts. Got it? Invisible but deadly, pulling in matter all around it. Even light can't escape. Not to worry. Supernovas are rare. A galaxy like ours, of 100 million stars, may experience only one exploding star in a century.
So, who else better to teach you about black holes and singularities than Homer Simpson himself?
Man, this place looks expensive. I feel like I'm wasting a fortune just standing here. Better make the most of it. Ow! Watch it, Coney! Oops.
Do you see a light, Homer?
Yes?
Move into the light, my son.
No!
Homer, this is your physician, Dr. Julius Hibbert. Can you tell us what it's like in there?
It's like, did anyone see the movie Tron?
No.
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 No. No.
No.
No.
No.
No. No.
Yes. I mean, no. No.
Well, where's my dad?
Well, it should be obvious to even the most dim-witted individual who holds an advanced degree in hyperbolic topology that Homer Simpson has stumbled into the third dimension.
Sorry.
Here is an ordinary square. Whoa, slow down, egghead. But suppose we extend the square beyond the 2 dimensions of our universe along the hypothetical z-axis there. This forms a 3-dimensional object known as a cube or a frinkahedron in honor of its discoverer. Hey.
Help me! Are you helping me or are you going on and on?
Oh, right, and of course within we find the doomed individual. Enough of your borax, Poindexter. Man's life is at stake. We need action. Take that, you lousy dimension!
There's so much I don't know about astrophysics. I wish I read that book by that wheelchair guy. I'll save Homer. All I need is 4 stout men to work the bellows.
No, Pops, it's too risky. For all we know, there could be cubes in there the size of gorillas and other large.
Help! I don't have much time.
That does it. I'm going in.
No!
Cool, man.
Oh my god, I'm gonna be sucked into a black hole. I'm gonna be sucked into oblivion. I'm gonna be nothing. And what's gonna be coming out the other side? I don't know.
I'll save you, Dad. I can't get any closer. You'll have to jump.
Here's the cake, son. Crack, 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 crack.
What happened?
Well, we hit a little snag when the universe sort of collapsed on itself. But Dad seemed cautiously optimistic.
Homie.
Be strong, Marge. I'm sure he's gone to a better place.
This is the worst place yet.
So hopefully you enjoyed that. Again, just a little cartoon version there. But some people believe that once you fall through a black hole, you may end up in a different dimension. Okay. Or, no one really knows because we've never been able to send anything out or send probes in to do anything. I think that's something that may happen in your guys' lifetime. Who knows? Lastly, what about low mass stars? So we talked about our sun, which is an average mass, and then we talked about a large mass, which goes like big bad supernova creates black holes. But what about low mass stars? Well, the answer is very simple. We don't know. Okay, it all starts out with a nebula. We see the protostar; it becomes a main sequence, and when we see it in the main sequence, it only lasts for a little bit of time. Now, when I say a little bit of time, we're still talking about a million years or something. But as soon as we start trying to study it, or as soon as that light is able to reach Earth, like we talked about, by the time we kind of zero in on it and find it and kind of really start to study it, it kind of just disappears. It just goes away or burns out or something like that. So we really don't know what the next evolution after it's in the main sequence, other than maybe just burning out, maybe like a black dwarf or whatever it does. We really don't know at this point what it does. So hopefully you enjoyed this section. Again, this was this is part 3 of your notes, Life Cycle of the Stars. You are going to do a Schoology assignment where you're going to kind of match up, and you just need to know what is the order of each stage, and that's kind of what you're going to do. Again, notes were a little longer because I integrated the videos into it, but other than that, have a wonderful day. Mr. Tima